Hi everyone, today we will look at a simple but serious bug called broken access control. In this example, a cookie from the user's browser decides who is an admin. Here is the agenda what we will go through in this video. First we'll go through what broken access control means, why it happens, a real example, a quick demo showing how a cookie change gives admin access, how developers can fix it with proper code, and also a little bit of discussion on how to test, monitor and prevent it in the future. Broken access control means the app doesn't properly check who is allowed to do what. It's not about logging in, that's an authentication. This is about permission, who can access or change what. A common mistake in trusting anything that comes from the user's browser, like a cookie or a hidden field. If your server believes whatever the client sends, you don't have a security check, you have a security hole. So why does this happen? Now you might be thinking, this seems like a pretty obvious mistake. Why would any developer ever do this? But here's the thing, even smart, experienced developers make this mistake not because they are careless, but because real-world projects are messy. Deadlines are tight, features get rushed, and sometimes shortcuts slip through. Here are 5 common reasons this kind of broken access control bug appears, even in well-funded teams. First, trusting the client side. Sometimes the backend sets a cookie like isAdmin equal true, assuming only the server will touch it. But here's the truth, anything is stored on the client can be tampered with. The user can open DevTools and change isAdmin equal to false to true in 2 seconds flat. And if your server trusts that cookie, you have just handed them the admin keys. Second, UI only security. This is where developers hide admin buttons in the interface for normal users, but forget to secure the backend. So yes, the dashboard looks fine, the seller user can't see the admin features, but if they open the burp or type the API URL manually, the backend lets them in because it never actually checks their role. That's like locking your door but leaving the window wide open. Third, inconsistent checks. Maybe one root checks if the user is an admin, but another root written later doesn't. Maybe someone copy-pasted a similar function and forgot to add the rule check. This is especially common in large code bases with many developers working in parallel. Fourth, no central rule or shared logic. So this is a big one. When each root or controller handles its own authorization checks with no shared middleware or function, things drift. One root uses if user.role equal to admin, another checks request.cookies, and third one relies on some flag in the session. Without a central place to define who can access what, inconsistencies creep in, and that's exactly how bugs like this show up. Fifth, legacy code and shortcuts. This happens when older parts of the app were built with weak or missing security checks. Maybe the first version of the app just trusted cookies. Over time, new features were added, but nobody refactored the old logic. So now you have new code that's secure sitting next to old code that's wide open. And guess what? Attackers will always find the weakest path. So now that we understand why this happens, let's look at how to demo it and then how to fix it the right way. Let's start by looking at our demo application. We are running the insecure version of the web that contains intentional vulnerabilities for educational purposes. So we have credentials for regular user and admin user, and these are the instructions to check the cookies. So let's start by logging in as a regular user. So this is, for example, a seller account with the standard user privileges. I entered the seller credentials, and these are which are already provided. Now I'm logged in into the dashboard. Notice the user information shows we are logged in as a seller at test.com with the role of the seller. This is important. We are definitely a standard user, not an administrator. This user should only have access to the basic seller functions, not administrative features. Now comes the interesting part. Let's examine what is happening behind the scene by looking at browser's cookie. I'll open the developer tools by pressing function F12 and applications, cookies, and here is what it gets dangerous. Look at this cookie called m_admin user. It's currently set to no. This cookie is what application uses to determine whether a user has administrative privileges. This is a critical security flaw. The application is trusting client-side data, something that users have complete control over to make access control decisions. Now watch what happens when I simply double-click on this value and change it from no to yes, and I'll press enter to save this change. That's it. I have just told the application that I am an administrator, but I am still logged in as the same seller account. Now let's see if this simple cookie modification actually grants me an administrative access. I'll refresh the page to make the application re-evaluate my credentials. The page has completely changed. Notice that an admin panel link is now appeared in the navigation area. The user information still correctly shows that I am logged in as a seller at test.com account, but the application now believes I have administrative privilege. With just one simple cookie change, I have successfully escalated my privileges from a regular user to an administrator. Let's see what damage I can do by clicking on the admin panel. And here you can see I now have full access to the administrative control panel. Even though I am still logged in as a regular seller account, I can change the application title, toggle security features, and access user management functions. These are clearly sensitive operations that should only be available to legitimate administrators. This vulnerability has a massive security implications. Any authenticated users can instantly become an administrator. No special tools or advanced hacking skills required, just basic browser knowledge and complete system compromise is possible. Attackers could modify critical settings, access sensitive data, or even create new admin accounts. This is why client-side controls should never ever be trusted for security decisions. Cookies, hidden from form fields, JavaScript variables, anything that lives on the client side can be modified by the user with malicious intent. The fundamental rule is never trust the client. All security decisions must be made server side based on proper authenticated and authorized session data. So what could be the impact of this? Let's talk about the real world impact of this issue and why developers, testers, and business leaders should all care. If an attacker can make themselves an admin just by changing a cookie, they can do a lot of damage. They can change key settings or configurations. They can download private user data like names, emails, or even payment details. They might manipulate payment flows such as changing prices, discount rules, or refund logic. They could add backdoors or change other users' roles. And worst case, they lock out the real admins and take over the whole platform. This isn't just a tech bug, it becomes a security breach that could lead to loss of customer trust, get your company into legal trouble, and possibly bring heavy fines from regulators, especially if user data is exposed. Now imagine this flaw exists in a payment platform or a healthcare system. The risk isn't just financial. It could involve sensitive personal or medical data, and that makes the consequences even more serious. So yes, a simple bug like this can become a big headline if left unchecked. So how to fix it? Thankfully, the fix is not complicated, but it needs to be done properly. There are 3 golden rules every developer should follow when it comes to access control. First, make all role decisions on the server side. Never trust cookies or hidden fields to decide if someone is an admin. Use the server's session or database. Secondly, use centralized authorization. Don't repeat access checks in different places. Use middleware, filters, or a shared method to decide who is allowed to do what. And third, deny by default. If your code doesn't clearly allow a user to access something, block it. Don't assume anything unless it's explicitly checked. These three simple steps can stop most privilege escalation bugs before they ever reach production. Now let's look at a few extra safety tips you can use to make your app more secure, even beyond fixing the main bug. First, take care of your cookies. Make sure sensitive cookies are marked as HTTP only, secure, and set to same site equal to strict. This won't stop access control bugs, but it does protect you from attacks like cross-site scripting or cross-site request forgery. Second, whenever a user logs in or their role changes, like becoming an admin, rotate their session ID. This makes sure attackers can't hijack older sessions with higher privileges. Third, use a server-side role store. Even if you store role info in a session, double check it against the database for any important admin actions. This helps prevent abuse if sessions are tampered or left outdated. Next, follow the principle of least privilege. Only give admin access to what's truly needed and nothing more. Avoid creating super admin roles that can do everything unless absolutely required. And finally, enable audit logs. Every admin action should log the user ID, IP address, session ID, and timestamp. Set up alerts for unusual behavior like sellers suddenly accessing admin features. These extra steps won't fix the bugs on their own, but together they make your app more harder to attack and easier to monitor if something goes wrong. And then there is one final point on detection and monitoring. So this is how we can detect and respond to this kind of vulnerability in real system. First, we should have SIM rules which can help. So if an admin level action is triggered by a user who isn't an admin, raise an alert. Second, a WAF rule can temporarily block suspicious requests, like those with a cookie admin user equal to yes targeting admin endpoints. It's not a fix, just a band-aid until code is corrected. Third, use anomaly detection. Watch for sudden spikes in admin actions from low privilege accounts. That's a red flag. Fourth, after deployment, run automated replay attack scans to test for cookie tampering vulnerabilities. And remember, don't rely on WAF forever. It's a short-term shield, not a long-term solution. To wrap up, broken access control via client-side cookie manipulation is easy to exploit and catastrophic in impact. Fix it by enforcing server-side, centralized RBAC, adding test and monitoring. Thanks for watching. Stay curious and secure.